Hi dear students, good morning to all. Today in our video there are two sections. In the first section we are discussing the exercise part of our chapter soil, and the next part is our new chapter motion and time. So listen carefully and write the two exercises. Soil. First question. In addition to the rock particles, the soil contains air and water, water and plants, minerals, organic matter, air and water, water, air and plants. So we know that in addition to the rock particles, the soil contains minerals, organic matter, air and water. So third one is the answer. Then second question, the water holding capacity is the highest in water holding capacity in sandy soil, clay soil, loamy soil and mixture of sand and loam. We know that clay soil have high water holding capacity, highest. Okay, next one, third one. Match the items in column 1 with those in column 2. A home for living organisms. Upper layer of the soil, sandy soil. Middle layer of the soil, clay soil. A home for living organisms. Yes. What is the answer? What should be the answer? Now that all kinds of soil are a home for living organisms. Third one, second one, upper layer of the soil is known as what? Is it dark in color, or it is large particles, small particles and packed tight, or lesser amount of humus? So it is dark in color. Next one, sandy soil, it is large particle. Sandy soil, sand, it is a large particle. Fourth one, middle layer of the soil contain lesser amount of humus. Fifth one, clay soil is small particles and packed tight. Next question, explain how soil is formed. We know that soil is formed due to the weathering of rocks. The process known as weathering. Weathering is a process in which physical breakdown and chemical decomposition of minerals takes place primarily by wind, water and climatic change. In the weathering process, rocks are converted into small pieces which eventually turn to soil particles to form a layer of soil. We know that weathering of rocks is known as what? Yes, soil is formed by the weathering of rocks. Next question, how is clay soil useful for crops? We know that clay soil is useful for crops because of the following reasons. First one, it has excellent water holding capacity, and also it is rich in organic matter, and this clay and loamy soils are suitable for growing cereals like wheat. Water holding capacity of clay soil supports the growth of crops like paddy, which require more water to grow. So we say that this clay soil is good for crops. Next question. List the differences between clay soil and sandy soil. What are the differences? In our last video we discussed about this clay soil and sandy soil very deeply. So it is very easy to find answer. So in clay soil, particles are fine, small particles, and also particles are tightly packed. packed, and also the water holding capacity is high in clay soils. It is heavy in weight and rich in humus and organic nutrients. But sandy soil, this is larger particles and also loosely packed. These particles are loosely packed and the water holding capacity is very low. It is light in weight and is not rich in humus and organic matter. Okay, then very little air is trapped between the particles in clay soils. But in sandy soil, it is more aerated. More air is trapped between the particles. Next question, sketch the cross section of soil and label the various layers. So, sketch the soil profile. We know that soil profile contains A horizon, B horizon, C horizon and bedrock. So, you should sketch this diagram. Next one, 8th one. Recia conducted an experiment in the field related to the rate of percolation. He observed that it took 40 minutes for 200 ml of water to percolate through the soil sample. Calculate the rate of percolation. Given here, amount of water is given 200 ml and percolation time also given 40 minutes. So we know that the percolation rate we can find it by using the following equation. Amount of water in ml divided by percolation time in minutes. So we get 200 ml by 40 minutes is equal to 5 ml per minute. 5 milliliter per minute. So it will be the answer. 9th one, explain how soil pollution and soil erosion could be prevented. This is very simple question and it is a general question. We know that soil pollution can be controlled by the following measures. By reducing the use of plastics, we can reduce soil pollution, and also by controlling the use of chemical fertilizers and pesticides, we can control soil pollution. And soil erosion can be controlled by taking the following step. What? Yes, planting more and more trees will result in the reduction of soil erosion, and also by stopping deforestation and avoiding overgrazing of animals. Okay, these are the prevention against soil erosion and soil pollution. Okay, this is the first part. Now we can move to the second part, that is our new chapter. We can start. Motion and time, chapter 13. This is physics chapter. So in your class 6 you learned about different types of motions. You learned that a motion could be along a straight line, it could be circular or periodic. You can recall these 3 types of motion. Some examples of different types of motions are given. First one, soldiers in a march past. So we know that soldiers in a march past. Yes, what is the type of motion? Is it straight line or circular or periodic? Yes, it is straight line, straight, right? Second one, hands of an athlete in a race. Yes, is it circular or straight line? No, it is periodic motion, right? Third one, pedal of a bicycle in motion. It is a circular motion. Motion of the earth around the sun, it is also circular motion. Fifth one, motion of a swing. It is also periodic motion. Now it is common experience that the motion of some objects is slow, while that of some others is fast. When we compare two pictures, this picture 1 and 2, we can note that first picture is vehicles moving in the same direction on a road. Second picture is the position of vehicles shown in figure after some time. So in this picture we can see that this green color car is at a very speed. Speed of the green color car is high, right? You are probably familiar with the word speed. In this example, a higher speed seems to indicate that a given distance has been covered in a shorter time, or a large distance covered in a given time. In a shorter time, large distance covered. Which object covered large distance in a shorter time? It has higher speed, right? The most convenient way to find out which of the two or more objects is moving faster is to compare the distances moved by them in a unit time. Thus, if we know that the distance covered by 2 buses in 1 hour, we can tell which one is slower. We call the distance covered by an object in a unit time as the speed of the object. Okay. So, speed is the total distance covered divided by the total time taken. Or we can say that distance covered by an object in a unit time is called what? Speed. So, speed is equal to total distance covered divided by total time taken. This is the equation. Okay. So, we can determine the speed of a given object once we can measure the time taken by it to cover a certain distance. Next one, measurement of time. How we will measure time? If you did not have a clock, how would you decide what time of the day it is? Have you ever wondered how our elders could tell the approximate time of the day by just looking at shadows? How do we measure time interval of a month, a year? Our ancestors noticed that many events in nature repeat themselves after definite intervals of time. For example, they found that the sun rises every day in the morning. The time between the one sunrise and the next was called what? A day. Similarly, a month was measured from one new moon to the next. A year was fixed as a time taken by the earth to complete one revolution of the sun. Often we need to measure intervals of time which are much shorter than a day. So the working of clocks is rather complex, but all of them make us use of some periodic motion. One of the most well-known periodic motion is that of a simple pendulum. Okay, a simple pendulum. So a simple pendulum consists of a small metallic ball or a piece of stone suspended from a rigid stand by a thread. Yes, this is the simple pendulum. Here, a simple pendulum consists of a bob, metallic ball or a piece of stone piece suspended from a rigid stand by the thread. This metallic ball is called what? The bob of the pendulum. Okay, this rose-colored metallic ball is called what? Bob of the pendulum. So this first picture shows the pendulum at rest. It does not in a motion. In its mean position. When the bob of the pendulum is released after taking it slightly to one side, it begins to move to and fro. The to and fro motion of a simple pendulum is an example of a periodic or an oscillatory motion. It is an example of this periodic motion is an example of an oscillatory motion or a periodic motion. Simple pendulum. Okay, a pendulum is said to have complete completed one oscillation. When its bob started from its mean position. This is its mean position. Okay, this is its mean position. When the bob starting from its mean position and moves to A. Okay, the mean position is B. Here mean position is B, and its bob starting from its mean position and moves to A and back to B. Then the pendulum also complete one oscillation when its bobs move from one extreme position C to B. Okay. So, the time taken by a pendulum to complete one oscillation is called its time period. What do you mean by time period? The time taken by a pendulum to complete one oscillation, to complete its one oscillation. So, we can say that this is time period. Yes, it is the motion of simple pendulum. So, a simple pendulum consists of a small metallic ball or a piece of stone suspended from a rigid stand by a thread. The metallic ball is called the bob of the pendulum. The time taken by the pendulum to complete one oscillation is called its time period. Next one, units of time and speed. What are the units? We know that the unit of time is what? Second. The basic unit of time is second. S. Larger units of time are minutes and hours. The basic unit of speed is meter per second or meter per minute or kilometer per hour. Next one, measuring speed. How we measure speed? Having learned how to measure time and distance, you can calculate the speed of an object. Let us find out the speed of object. Okay. You may now like to compare your speed of walking or cycling with that of your friends. Right? And also, you are very familiar with, you might have seen a meter fitted on top of a scooter or a motorcycle. Similarly, meters can be seen on the dashboards of cars, buses and other vehicles. So, this meter is known as what? Speedometer. It records the speed directly in kilometer per hour. Okay. There is also another meter that measures the distance moved by the vehicle. Yes, this meter is known as an odometer. To measure the distance moved by the vehicles. Okay. Next one, distance time graph.
Distance time graphs. Plotting distance against time can tell you a lot about motion. Let's look at the axes. Time is always plotted on the x-axis, bottom of the graph. The further to the right on the axis, the longer the time from the start. Distance is plotted on the y-axis, side of the graph. The higher the graph, the further from the start. If an object is not moving, a horizontal line is shown on a distance time graph. We can see that the time is increasing to the right, but its distance does not change. It is not moving. We say it is at rest. If an object is moving at a constant speed, it means it has the same increase in distance in a given time. In the graph we can see that time is increasing to the right and distance is increasing constantly with time. This means the object moves at a constant speed. Constant speed is shown by straight lines on a graph.
Now we can move to the next session, our exercise part. First question. Classify the following as motion along a straight line, circular or oscillatory motion. First one, motion of your hands while running. We know that is a which motion? Yes, it is oscillatory motion or periodic motion. Second one, motion of a horse pulling a cart on a straight road. So it is a straight road, it is a straight line motion. Third one, motion of a child in a merry-go-round. So it is also circular, it is a merry-go-round, so it is a circular motion. Fourth one, motion of a child on a seesaw. Seesaw, so it is a periodic motion or oscillatory motion. Motion of the hammer of an electric bell. It is also oscillatory motion. Motion of a train on a straight bridge. This is straight line motion. Next one. Which of the following are not correct? The basic unit of time is second. It is correct. Second one, every object moves with a constant speed. Is it correct? No. It is incorrect. Third one, distances between two cities are measured in kilometers. It is also correct. Fourth one, the time period of a given pendulum is constant. It is incorrect. No, it is not constant. Fifth one, the speed of a train is expressed in meter per hour. Is it correct? No, it is not correct. So the incorrect statements are second one, fourth one and fifth one. Third one is a problem. A simple pendulum takes 32 seconds to complete 20 oscillations. What is the time period of the pendulum? What do you mean by time period? Yes, time taken to complete one oscillation. So here number of oscillations is given, 20 oscillations, and the total time taken to complete 20 oscillations is what? 32 seconds. So it is very simple to calculate. So time period is equal to what? Total time taken divided by number of oscillations is equal to 32 divided by 20, 1.6 second. Okay, it is very simple. Next one. In this chapter, there are so many problems. Okay, fourth one, the distance between two stations is 240 km. A train takes 4 hours to cover this distance. Calculate the speed of the train. It's very simple. So here given distance between two stations is 240 km. The total time taken is what? 4 hours per 240 minutes. Total time taken. Now that 4 hours per 240 minutes. So speed is equal to distance by time. 240 divided by 4. Okay. So 60 km per hour is the speed. What is the unit of speed? Kilometer per hour. Okay. Then next one, the odometer of a car reads 57,321. Okay. 0.0 kilometer. When the clock shows the time 8:30 a.m., what is the distance moved by the car if at 8:50 a.m. the odometer reading has changed to 57,336 km. Calculate the speed of the car in kilometer per minute during this time. Express the speed in kilometer per hour also. So, Here the given initial reading of the odometer. What is the initial reading of the odometer? Yes, 57,321 kilometer. Okay. Now, final reading of the odometer was 57,336 kilometer. Then, distance covered by the car is given by, we know that the final reading of the odometer minus initial reading of the odometer will give the distance covered by the car. So, we can minimize. Okay. So, we get 15 kilometer. Initial reading of the odometer, final reading of the odometer minus initial reading of the odometer. So we get 15 kilometers. And the time, the starting time of car is 8:30 and it stops at 8:50. Hence, time taken by the car is equal to what? What is the time taken? 20 minutes. Okay. Now, we can calculate the speed. Speed is equal to distance by time. So, distance 15 divided by 20. Okay. Total distance is 15 kilometer. This is the distance covered by the car and divided by 20 minutes. So, we get the speed. Okay. What is speed? 15 by 20 is equal to 0.75 kilometer per minute. Okay. So, we get the answer in kilometer per minute. Okay. Then what is the question? In kilometer per minute and also in the express the speed in kilometer per hour. So we can convert this kilometer per minute into kilometer per hour. How we convert it? So 20 minutes. This minutes is converted into hour by dividing by 60. Okay, per 20 minutes is equal to 20 divided by 60. So 1 by 3 hour. So speed is equal to distance covered divided by time taken. So distance is the same, 15 divided by time taken is 1 by 3. So this 3 is put 3 in the above, 3 into 15 is equal to 45 kilometer per hour. Clear? Okay, here we find in kilometer per minute, speed in kilometer per minute. Then this is converted into kilometer per hour by dividing 60. Okay. Next question, sixth one. Selma takes 15 minutes from her house to reach her school on a bicycle. If the bicycle has a speed of 2 meters per second, calculate the distance between her house and the school. So here we can find out the distance, time and also the speed is given. So time taken by Selma to reach her school by bicycle is 15 minutes. So we can convert it into second by multiplying with 60. 15 into 60 is equal to 90 seconds. Second. Then speed of Selma's bicycle is 2 meters per second. So speed is equal to distance covered by time. So distance is equal to what? Speed into time. Okay, so 2 into 900. So 1800 meter. So this 1000 meter is equal to 1 kilometer. So 1800 meter is equal to 1800 divided by 1000. So we get what? We get the answer 1.8 kilometer. Okay. Next question. Show the shape of the distance time graph for the motion of the following cases. A car moving with a constant speed. Then what is the time distance graph? At a constant speed. So as the time increases, distance is a constant. Okay. So this is straight line. Second one. A car parked on a side road. So a car is does not move as time pass. It does not move. So it is the time distance graph. Eighth one, which of the following relations is correct? Speed is equal to distance into time. Which of the following relations is correct? First one, speed is equal to distance into time. Second one, speed is equal to distance by time. Third one, speed is equal to time by distance. Fourth one, speed is equal to 1 by distance into time. Which one is correct? Yes, speed is equal to distance by time. Next question. The basic unit of speed is what? Kilometer per minute, meter per minute, kilometer per hour and meter per second. Yes, meter per second. Next question. A car moves with a speed of 40 km per hour for 15 minutes and then with a speed of 60 km per hour for the next 15 minutes. The total distance covered by the car is dash. So here calculations, when the speed of the car is 40 km per hour, time taken is equal to 15 minutes. It can be converted into hour. So 15 by 60 is equal to 0.25 hour. Then speed is equal to distance divided by time. So distance is equal to what? Speed into time. So 40 into 0.25 is equal to 10 km. When the speed of the car is 60 km per hour, what will be the distance covered by the car? So distance covered d2 is equal to speed into time. So is equal to 60 into 0.25 is equal to 15 km. Here total distance covered by the car is d1 by d2. Okay, so 10 plus 15 is equal to 25 kilometers. Next question. Suppose there are two photographs had been taken at an interval of 10 seconds. If a distance of 100 meters is shown by 1 centimeter in these photographs, calculate the speed of the fastest car. What is the speed of the fastest car? So, the distance covered by the blue car, as evident from the photograph, from one horizontal white strip to another, which is measured by scale of 1.2 centimeter. So, it is given that 1 centimeter is equivalent to 100 meter. Therefore, 1.2 centimeter is equivalent to what? 120 meter. Right? So, distance covered by the car is equal to 120 meter. Then time taken to cover this distance is equal to time interval between the two photographs. That is 10 seconds. So, speed is equal to distance covered divided by time taken. So, it is 120 divided by 10. So, we get 12 meter per second. It is very simple questions. Next question. Here shows the distance time graph for the motion of two vehicles A and B. Which one of them is moving faster? Okay, A and B. We can say that vehicle A is moving faster than vehicle B. From this graph we can say that A is moving faster than B. Next question, which of the following distance time graph shows a truck moving with a speed which is not constant? So when we check first, this is a constant, this straight line, it's a constant speed, and also second is also truck is not moving. Okay, then fourth one is also a straight line, so it is also in a straight line, but third graph is not straight, so it is not constant. So the answer is third graph. Thank you, students.